Okay, so number 1 says a population of 100 bacteria increases by a factor of 3 every day. Write a function that gives a population at any time, t and days. So first we got to see our starting point. And our starting point is this 100 right there. That's our initial value. Okay, and our initial value goes right here before, oops, should not have done this one. No B and no C. Initial value goes right here before the parentheses. Now, the factor, that 3, goes inside the parentheses. That's how quickly it's growing. And then this t, this time, is going to go here outside. Because we don't know how many days, it's our exponential value. So this answer is A. Number 2, under ideal conditions, the number of rabbits in a certain area doubles. So that means 2 every month. Write the function that gives the population in time t months if originally there were 40 rabbits. So our initial value is the value that's outside of the parentheses. That is 40 right here, these two. Now remember, the value that it's going to grow is inside the parentheses, that 2, and then t is the number of months that it grows by. So this one, ooh, that looks ugly, sorry, is C. Okay. Number 3, on Monday, there were 5 people with the flu. On Tuesday, there were 15. On Wednesday, there were 45. Which function best and description best fits the problem? So, on the first day, there were 5 people. That's your initial value outside of the parentheses. So it's not D and it's not A. We have a 5 here and a 5 there. Okay, so let's do our t-chart here, X and Y. So on the first day, there were 5. On the second day, there were 15. And on the third day, there were 45. So 5 times 3 will give you 15, and 15 times 3 will give you 45. So it's growing by 3. That would be B. So number 4, if a population that grows exponentially is 500 initially and doubles every year, what is the rate of population growing after 2 years? So it's this doubles. How is it growing? Doubles means times 2. So that's your C. Let's see. 6, scientists are studying a bacteria sample. This is your function right here. Gives the number of bacteria samples at the end of the day. Remember, 245 is your initial value, and 1.12 is your growth rate. And next is the time, how long it's going to take. So which statement is the best interpretation? So the initial value is 12. Nope, we know that's not true. B says the initial bacteria decreases as a rate of 88%. It's not decreasing, it says that it's growing. C says it increases at 12% each day. No, it's increasing at 1.12. And then it says the number of bacteria at the end of day 1 is 245, and that is true because that is your initial value there. 6, a young channel catfish weighs 0.1 pound. During the next few weeks, its weight increases by 20%. So we got an initial value right here, 23%, or that's its growth rate, and then t time. Okay, so we want that 0.1 for initial value. So let's cross out our B. And our growth is 23%. But none of these, this one and this one isn't in percentage. We know it's not C. the way you're going to write that is 1.23, and it seems a little confusing. But you got to add that 1 in front of there. Okay, so after 4 weeks. So if we plug in this, let me go over here. Skip for now, skip always. Y equals, let me see that equation. 0.1 parentheses, point 1.23, do this again, 0.1 parentheses, 2, 3 parentheses, to the x, and let's go to our table, and we're looking for 4. 4 says 0.2288. Or 0.229. Just plug that into our table. Number 8. An SUV that is originally worth $5,000 depreciates $50,000. It goes down. So this is our initial value, this $50,000, by a factor of 5 every year. Find a function. So instead of multiplying by 5, we're going to divide by 5. That one is C. Oops. Okay. After 3 years, so we're going to put that once again here. Let's clear this. 50, 3, and then alpha y equals fraction 1/5, close parentheses, x, and then second table, and it says how many years? After 3 years. So after, I'm trying to go positive, after 3 years it says $400. Whoa. Sorry. That one would be A. Okay, so we have this function right here. Remember, 22 is the initial value, 0.94 is the growth rate, and t is the time. Y is the population after t years. Identify the initial amount, which we said was 22, and the growth or decay factor, so it's growing by 94%. And that one's B.